let's systematically name some carboxylic acid. So let's say I had a molecule that looked like this. Clearly a carboxylic acid. We have a carboxyl group right over here. Now, to name it systematically, we do it just the way we've named our simple alkenes. When we first learned how to name any organic molecule, you look for the longest carbon chain. And the longest carbon chain is 1, 2, 3, 4 carbons. So our prefix will be but. So it's butan. And instead of calling it butane, instead of writing this E here, we know this is a carboxylic acid. It has this carboxyl group. So we call it butanoic acid. And now you might wonder, hey, don't we have to specify where the carboxyl group is? And if you look at how carboxylic acids are arranged, you can tell that the carboxyl group is always going to be at one end of a carbon chain. So you don't have to specify. And in fact, you always want to start numbering at wherever the carboxyl carbon is. So if you had to number these, this would be the 1 carbon, the 2, the 3, and the 4. So you don't have to specify a number for the carboxyl group. Let's do another one. Let's say we had something that looked like this. Let's say we had something that looked, let me put another carbon on there, just like that. And let's say that there's a methyl group. Let's say that there's a methyl group right over there. Now, clearly a carboxylic acid, but to name it systematically, we just want to find the longest carbon chain. So we have 1, 2, 3, 4, 5, 6 carbons. So our prefix will be hex. So it's hexan. It is hexan. And it's clearly not just a hexane. It's a hexanoic acid. It has this carboxyl group right here. This is hexanoic acid. And we're not done because we still have this methyl carbon right over here. And it is on the, we always want to start numbering at this carbonyl carbon. 1, 2, 3, 4, 5, 6. It is at the number 3 carbon. So this is 3-methyl hexanoic acid. Let's do one more. Let's say we had a molecule that looked like this. Let's see, that's 1, 2, 3, 4, 5, 6, 7 carbons. And then we have our carboxyl group, just like that. And let's say that we had a double bond right over there. What would we call this? Well, once again, look for the longest carbon chain. Longest carbon chain. We have 1, 2, 3, 4, 5, 6, 7 carbons. So the prefix is hept. So it's heptan. We won't just, and actually let me be careful. This isn't an alkane. This has a double bond right here. This has a double bond right over here. So it's heptene. If this was just an alkene, we would just call it heptene. But we're not going to put this last E here because this is the carboxylic acid. And to specify where that double bond is, we need to start numbering. And we start numbering at the carbonyl carbon. 1, 2, 3, 4, 5, 6, 7. So you could either name this 3-heptene, and well, I haven't finished it yet. I haven't put this final E over here. Or you could name it hept3ene, just like that. This is the more typical one that you would see because it tells you, okay, we have a double bond and it starts at the number 3 carbon, goes from the 3 to the 4 carbon. But this isn't just a regular alkene. This is a carboxylic acid. So instead of writing that final E here for an alkene, we write it as, we have a carboxyl group right here. So this is 3-heptenoic acid. And we are done. And actually, if you wanted to get really fancy on this one right over here, you could see that these 2 carbons that are on the double bond, so this carbon and this carbon, it's kind of arranged like this. If you view this as, let me draw it like this. They both have other hydrogens out there that we didn't draw. They're implicitly there. But if you wanted to rewrite or redraw this molecule, you could draw it like this. You have 2 carbons just like this. This one has a hydrogen popping up like that. That one has a hydrogen popping down like that. And then this carbon over here has this big functional group over here. We'll call that R. So this is R. And then this one over here, I'll do it in green, has this other functional group, has these 3 carbons. We could call that R prime. These three carbons are R prime. And if you look at it this way, you're like, hey, look, the functional groups are on opposite sides of the double bond. They're away from each other. So if you wanted to, you could also call this trans. Trans. We could even write in italic. Trans 3-heptenoic acid. And this will specify that these guys are on opposite ends. But this is only if you're assuming that I kind of drew it in the actual three-dimensional configuration in some way. Anyway, hopefully you found that useful.